Have you ever just looked up at the night sky and wondered, why does the moon look different every single night? It's a question people have asked for, well, forever. And today, we're going to pull back the curtain on this amazing cosmic show.
Yeah, you know exactly what I'm talking about. One night it's this big, brilliant circle, and then a week later it's just this tiny little sliver. Or maybe it's not even there at all. So what gives? Why doesn't it just stick to one look? Well, the secret, and this is the really cool part, is that the moon isn't changing at all. We are. Or rather, our view of it from right here on Earth is what's changing. It's all about our perspective in this big cosmic dance. Okay, so first things first, let's get one thing straight. The moon isn't some giant light bulb floating in space. It doesn't make its own light. So where is all that beautiful silvery glow actually coming from? Here's the deal. All that moonlight you see, it's really just secondhand sunlight. The moon is basically a giant dusty mirror. Just like our planet, one half of the moon is always lit up by the sun. That's its day side. And the other half is in total darkness. The phases we see, that's just us catching different glimpses of that sunlit half as the moon circles around us.
And this journey, this orbit, creates this amazing, totally predictable cycle of 8 different phases. It's like a celestial clock, and we're going to walk through the whole thing, step by step.
Okay, so it all kicks off with the new moon. This is when the moon is hanging out between us and the sun. From our point of view, the side facing us is completely dark. We can't see it. But then a little bit of light starts to peek out. This is called waxing. Think of it as the light growing. First, we get a tiny waxing crescent, and then, about a week into the cycle, bam! We hit the first quarter, where it looks like a perfect half moon. From there, it keeps on growing into what we call the waxing gibbous phase.
And hey, here's a fun little tidbit for you. Ever seen the moon during the day? Like you look up in the afternoon and there it is, plain as day? Chances are you were looking at a first quarter moon. It's because of the very specific geometry of where the sun, earth, and moon are at that moment. Pretty cool, right?
So that weird word gibbous, where does that even come from? Well, it actually comes from a Latin word that means hunchbacked. And when you think about it, that's kind of perfect, isn't it? It perfectly describes that lumpy, more than half full, but not quite a perfect circle shape. A little bit of ancient trivia for you. All right, so we're about 2 weeks in, and we get to the main event, the full moon. This is when Earth is sitting right between the sun and the moon, so we get a full, brilliant view of its entire sunlit side. It's spectacular. And from here on out, the process just goes in reverse. The light starts to fade, or as we say, it wanes. It goes from full to a waning gibbous, then to the third quarter, another half moon, and finally shrinks to a tiny waning crescent before, poof, it disappears back into the new moon, and the whole dance starts all over again.
Okay, so we've got the 8 phases down, but how long does this whole cycle actually take? A month, right? Well, yes and no. The answer is actually a little trickier and way more interesting than you might expect.
You'd think, how long is a lunar month, would have a simple answer, but it opens up this really fascinating little wrinkle in the clockwork of our solar system.
You see, it all comes down to what you're measuring against. There are actually 2 kinds of lunar months. First, there's the Synodic Month. That's the one we actually see, the time it takes to go from one new moon all the way back to the next new moon. But then there's the Sidereal Month. This is how long it truly takes the moon to do one complete lap around the Earth, using the faraway stars as a finish line. And here's the kicker. They're not the same length. So the Synodic Month, the one that matches the phases we see, clocks in at about 29.5 days. This is the rhythm humans have used for like forever. For calendars, for farming, for everything. It's the moon month we actually experience. But the moon's true orbit, the Sidereal Month, that's only about 27.3 days. That's more than 2 full days shorter. So what happened? Where did those other 2 days come from?
So what's up with that 2-day difference? Why the gap? Well, it's because this isn't just a two-body dance. There's a third, very important partner we've got to account for. Okay, here's the aha moment. As the moon is orbiting the Earth itself is moving. We're hurtling through space, orbiting the sun. So after the moon completes one full orbit around us, that's the Sidereal Month, we're not in the same spot anymore. We've moved along in our own orbit. The moon has to travel for about 2 extra days to catch up and get back into that perfect new moon alignment with us and the sun. It's like a cosmic chase.
So, when you boil it all down,
What you're seeing when you look at the phases of the moon isn't just about the Earth and the moon. It's a beautiful, intricate, three-body dance between the sun, the Earth, and the moon. It's the constantly shifting angles between all three of them that paints that changing picture in our night sky.
And that leaves us with one last little puzzle to think about. I mean, our word month obviously comes from moon, right? So if the moon's cycle is a super consistent 29.5 days, why is our calendar such a mess of 28, 30, and 31-day months? It kind of makes you think, doesn't it? It's a perfect reminder that even when the universe gives us a perfect clock, we humans always find a way to make things, well, a little more complicated.